Okay, so let's get started. We're going to be taking a look at setting up and working with advanced programming for water meth injection tuning found within our Link G5 and G4X systems. The tutorial is going to focus on building our own water meth injection system and then bringing in all the components, so setting up all the inputs and outputs so that we can control the system properly. We want to replace an AEM water meth control brain or an Aquamist water meth control brain. We want to replace that computer with the Link, so the Link is doing all of the work. So we're building the control from the Link with a pulse width modulated table. We're going to be integrating a fail-safe strategies within the Link so that if anything happens, we can shut down the engine and we don't run the engine lean with too much timing is what we'll find ourselves in if we have the water meth spraying and all of a sudden something happens and it stops spraying into the engine under boost. So very dangerous condition. We want to have that fail-safe all built in here to the Link. Now, last tutorial we talked about integrating an AEM or an Aquamist kit into the control strategy. This is going to replace that entire control brain and just do everything directly from the Link. I find that this is actually really effective, and I've done this on many vehicles, and it works extremely well. But we do have to go over the schematic and all the individual components in the system and talk about how the system should function as a whole. Then we're going to be setting up our inputs and outputs here, setting up our programming logic, setting up our 4D or 5D fuel and ignition compensation tables so that we can account for every aspect of the water meth as it's spraying into the engine. Or again, if something bad happens, a line pops off, something happens, we run low in water meth solution in our tank, we can account for all of that. So let's jump in here and take a look at the schematic first, then we're going to talk about how we set it up then in the software and then go through all of that programming. So coming up on screen, we have our schematic of what I've created here for a water meth kit. This is what I've used before. It works extremely well. So let's talk about all the components here in the schematic. So the first thing is we have a Link G5 here in the picture. It could be a G4X or a G5. Next, we have an on-off toggle switch. This toggle switch is generally going to be wired to a chassis or battery ground. So when we turn the switch on, it's our arming switch. That's going to be grounding the pin on the Link that is used to tell the Link that we want to start spraying the water meth. So it's essentially the arming switch, just like a nitrous arming switch. The next thing we have here is a solid state relay. The solid state relay is used to control the water pump in the system. The solid state relay is allowing us to pulse width modulate that water pump to control the pump speed and to control the water meth flow into the engine. The solid state relay in this case is something I use pretty frequently. It's Holley part number 15620NOS. It's meant for nitrous solid state relay control, but it works for pretty much anything. You can go all the way up to 1000 hertz in the frequency, and it handles a 40 amp continuous switching load. So it's a really versatile solid state relay, and it costs around $70 to $80 typically online. Pretty inexpensive, and it works well, and it's reliable. It's really key. So we find that solid state relays there. Then we also have our battery. So the battery is obviously going to be in your vehicle. We have our water meth tank. Now this just happens to be an AEM water meth tank. I typically choose a water meth tank that has a fluid level sensor built in. The AEM does. Very important because if we run low on fluid, we want the water meth system to shut down. We don't want to allow it to continue to try to spray any water meth, and we want to limit our engine from being able to run into a potentially dangerous condition. So we want to rev limit our engine when that level starts to drop. So that level sensor, pretty simple. That's one leg's going to go to our battery or chassis ground. The other leg is going to come into our Link, and that is literally an on-off switch, and it's going to be a ground on-off switch. So it's going to be grounding whatever pin we're wiring that to. So that's pretty simple. Then we have our water meth pump. In this case, I'm just displaying here an AEM water meth pump. They work pretty well. Their HD pump allows you to run 100% methanol mixture and not actually have any water. Sometimes I do that. I typically run a higher water meth mixture, or higher meth to water mixture, I should say, ratio. That gives you better cooling effect as well as a higher octane effect. Now, the water technically does a better job of cooling. However, it's not combustible. So we're going to get into a situation if we have 50-50 water meth solution and we're spraying a lot of it into the engine, that water will create misfiring problems for most ignition systems, and that's going to be a whole thing we want to avoid. I usually try to do a ratio of about 80 meth, 20 water, but your pump that you're using has to be able to handle those higher meth the meth mixtures. So the AEM HD pump can, that's what I've pictured here. Now we have after the pump, we have a 0 to 500 PSI stainless pressure sensor. You can use anything at least 200 PSI and greater. 0 to 1000 would work, 0 to 500, 0 to 250 is fine. We typically find when the pump's on, we build about 200 to 250 PSI of pressure. We want that pressure sensor integrated here into our system because if, let's just say, the tank is full, so the tank level is fine, but all of a sudden now we have a line that pops off coming out of the tank going to the pump or going from the pump to the check valve here, we're going to have a problem. And in that situation, we want to be able to monitor that pressure in the system because if the line pops off, it's the same thing as the running out of fluid. So it's a dangerous condition. The pressure sensor will allow us to monitor what's going on with the pressure. So we're going to have it located in our system right there. Now then next we have a check valve. The check valve is used to shut down the water meth flow going into the water meth nozzle. We use this so we don't have a siphoning effect in any of the water meth solution that's in the line after the pumps stops energizing and starting to run to build the pressure. This just makes sure that in lift throttle conditions coming into part throttle, we don't have any siphoning effect. So we use this in some specific situations, and we'll be controlling this from the link, and this will be a ground output to control this. Taking a look at this, this is, it could be either ground or it could be power output. The way that this is set up in the schematic, one leg of that's going to the battery ground, and then the other leg is going to be a high side output controlling it. But we could do either or. It doesn't really matter if it's high or low side. Then lastly, we find our water meth nozzle. This is what's going to complete the system. So this is what sprays the water meth solution into the engine. So pretty simple. All the components here are key to make this work for my strategy in this advanced water meth programming. So let's now start to take a look at programming some of this so that we have the basics and essentials accounted for. So the first three things that we need to set up here for our link, it's going to be the pressure sensor, that's going to be the on-off arming toggle switch, and that's going to be the fluid level sensor in the tank. Those are all inputs. The pressure sensor is an analog voltage input, and then the other two are general purpose inputs. Let's go and configure this based on what we're working with here because we're going to use this in our programming logic. So first thing we're going to jump into our analog voltage input, and we're going to use a general purpose pressure to account for the water meth line pressure. So we're going to go and type in a label here. We'll say water meth pressure. And then we're going to go to our source, and we need to go and wire it to an available analog input. I have analog voltage 5 here available, so we're going to wire it there. Next, we have our low and high errors. Now, this depends on the sensor that you're using. I am using a 0 to 500 PSI sensor. It's a linear calibration, so it's 0.5 volt is 0 PSI, 4.5 volt is going to be 500 PSI. I'm going to set the low error to something like 0.3 volt and then the high error to something like 4.7. I'm going to set it above and below the low and high voltage for that sensor scale. Again, the minimum volt is 0.5, the maximum is 4.5. If I fall below or above that, there's some kind of an error going on, and we want to go ahead and set this up. The error value, if this faults out, we're going to go and default it to 0 kPa. That's fine. The calibration here, we're going to go and set this to a linear calibration. We can use any of our linear calibrations that are available. All of them are taken up. I'm going to override this linear calibration too. Let's go here and point it to the linear cal2 table. And we're going to go ahead and redefine the linear cal2. The label here will be meth pressure. And we're going to go and set the minimum volt at 0.5, the maximum volt here at 4.5. The output units are going to be in units of pressure. And we need to go set the 0.5 volt associated pressure and the 4.5 volt associated pressure. I'm going to click U here and flip from units of kPa to PSI because my sensors rate it in PSI. I don't feel like doing the math conversion, converting PSI to kPa. So I'm going to set 0.5 volt, 0 PSI. 4.5 volt, we'll set it at 500 PSI. So simple there. If we flip back U, that brings us into our kPa reading, or units, so we converted that. So that's the first step. That's going to be our pressure sensor mounted between the pump and the check valve, and the check valve should be mounted right up against the water meth nozzle. So it shuts down, again, it doesn't allow any of that siphoning effect that happens. So set the pressure sensor. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.